Taking a look at 2024 question 2a. So a jeep of mass is moving up the hill and it's pulling a trailer of another mass. The hill is inclined at an angle theta. The jeep and the trailer move at a constant speed, so there's no acceleration on this one. Very important to note in a while. The engine of the jeep exerts a force of 440 up the hill, 4,400, excuse me, and the forces due to friction are given independently for both. Draw a diagram showing all the forces acting on the jeep. So in this case, no need to, just be careful when you're making sure to answer what's asked. So we're looking for the forces on the jeep. You don't need to draw the hill. I like to for my own sanity. I often recommend to my students you can do it in a slightly lighter pencil or different color. But here I'll do the forces in blue. So acting down, there is the weight, mg. The driving force up the hill here is the engine, so I'll call that E. We've got our reaction force, R. You don't need to draw the components in here of R. We'll do that in the next section. So we'll just show the forces, not the components of it. And then acting down the hill, I've got two forces of friction. The friction of the jeep, and I'll say the friction of the trailer, T. Okay. That there looks like all the forces, and in total, the examiner was awarding 10 marks for that bit there. So do take your time with the drawing of these diagrams, making sure to get your marks early on in those questions. Right, A part 2, calculate theta. So in this case here, I'm going to take my diagram from before, and I'm going to add on a little bit here. I'm going to add on showing this resolved into its perpendicular component and its parallel component. If this angle over here is theta, then this guy is also theta, making this W cosine theta, cosine because it's adjacent, and W sine theta because it's opposite. Now, we're looking for theta. So always in the question, we're either going to have to resolve it parallel to the plane or perpendicular to the plane. Okay. You can kind of start with either and see what happens. I'm going to start here though, because I just from experience, I'm going to start with the parallel to the plane. Now, a reminder, in the question, they said that they were moving at a constant speed. So there is no net force here, or the net force is 0. So what we're going to say here is, okay, if the net force is 0, that means the forces going up the plane are going to equal the forces going down the plane. And there are 3 forces going down. There's the friction of the jeep, friction of the trailer, and then the component of the weight. So in this case here, I'm going to say E equals F plus T plus W sine theta. Now, my E is 4,400. My F is 1525, the force of friction. The force of friction of my trailer was 375. My weight is mg sine theta. Now, just be really careful with the mg here. If you want, you can solve these as 2 separate things and realize that, you know, you have to do mg of both, okay? Or you can just put them together, right? 2375 plus 350. So 2375 plus 350 gives me 2725. So for the mass here, for mg, you can say 2725 g sine theta. And g as well, while I'm here, might as well put it in, is 9.8. So I can say 2725 by 9.8 sine theta. Now that I have that done, get everything over to the left. So 4,400 minus 1525 minus 375. I get it to be 2,500 equals, I'll just do that little 2725 multiplied by 9.8. I get 26705 sine theta. So theta to be 5.37 degrees, and I'll take it to 2 decimal places. Taking a look through the mark scheme as well, where are you getting the marks here? Well, you're getting 5 for getting to this stage, realizing plugging in the values correctly, and you're getting 5 for getting down to here. That's the end of A part 2. 2024 question 2 part B. So here we've got some pulleys set up as shown, and we're told that there's an inextensible string passes over them. We're given the 2 weights in newtons in the question, And we're told that the smooth pulley in the middle is 6.3 as shown in the diagram. System's released from rest. What we're going to do with this guy is we're going to assume always, doesn't really matter, it'll work out and tell you if you assume wrong. But here I'm going to say that the center pulley always moves down, right? So this guy's going to move up with an acceleration, and I'll say his acceleration upwards is A. This guy's also going to move up. I'll call his acceleration B. So this guy's going to move down with A plus B over 2. And that's going to be kind of key in there. But first it asks for the forces acting on the pulley while they're moving. So on the pulley and each of the weights. So I'll do each one here. So for the weight one, the force acting up is tension. I'm going to throw in my acceleration arrows just for myself when I go into the next section. The weight down here is 24.5 newtons. I'll just put in the value because we have it for W1. For the next one, for the pulley, tension up, and acting down is the weight. Well, it tells me it's 6.3, so it's mg, so you can grab your calculator, 6.3 by 9.8. You can plug it in as 61.74 newtons. And there's no harm in doing that, or you can say 6.3 g is perfectly fine as well. Then the last one here, my weight 2, acting upwards is the tension because it's all the same string. Acting downwards, from the question, I'm told it's 44.1 newtons. All of that together, and just see where the marks are going here. 5 for this one, 5 for this one, 5 for this one. That is lovely and friendly for picking up your attempt marks there. In each here, I'm just going to finish off by showing the direction of the accelerations. I'm calling that B, and down this way I'm saying it's A plus B all over 2. Okay, so looking at part 2, calculate the tension in the string. So what we're going to do is we're going to use our pre-existing stuff that we got here, and we're going to drop it down to here. So pasting it in, and we're going to basically solve for each of the 3 different weights each time. Now, because I've done these a few times, this is my first rodeo, I'm going to take out the middle one and do that last because that's got the more complicated bit of A and B. So let's see if we can make an equation for the first 2. Try to be as neat or succinct as possible here. So in this one here, I have it's accelerating upwards, so that must mean the tension is the greater force. So what I'm going to say here is the net force equals MA. The net force here is the tension minus 24.5 equals the mass. Now, to get the mass, I'm going to take the number 24.5. Let me just get rid of these marks from previously. 24.5, and I'm going to divide it by 9.8. So I grab my calculator and I say 24.5 divided by 9.8. I get 2.5. So 2.5A. I'm looking for A. Why am I getting A alone? Well, what we're hoping for in the end is to solve for T. So we're going to just eliminate the A in each case, or the A and the B. Rinse and repeat this idea for the second one. The net force here is MA. The net force here, again, it's moving upwards, I'm saying, so it's tension minus this part in the bottom. Tension minus 44.1 equals the mass. Same idea as before, do 44.1 divided by 9.8, and I get it to be 4.5. And I'm not using A this time, I'm saying it's B. Again, rearrange for B, T minus 44.1 over 4.5. We have our equation. I'm going to highlight them here in yellow. We have our equation for A. We have our equation for B. Next, I'm going to use them together to solve in here. So same idea again. It's moving down this time. The bigger force is the 61. So get rid of that marks there. So what I'm going to say here is, okay, the net force, always starting with this idea. I always start with this to remind myself. Net F equals MA. So I'm going to say 61.74 minus the 2 tensions equals the mass. They told me the mass and the question was 6.3, and it's A plus B over 2 for the acceleration. Cleaning this up, and this is where things get a bit messy, I actually find it easier at this point to not plug in A and B just yet. I'm going to do this. I'm going to say 6.3 divided by 2 gives me 3.15. Shouldn't need a calculator for that, Steve. 3.15 by A plus B. 61.74 minus equals 3.15a plus 3.15b. Now at this point, I think I might plug in the a and b, just because it's a bit nicer to look at. Still, it's going to be ugly fractions for a while. You know, you can solve this any way you like to solve fractions as long as it's correct. This is just the way I'm tackling it. You might do it differently. There's nothing wrong with that, as long as you're just doing it right. I'm going to do each number here, this divided by 2.5. And I get this to be a nice number. Since the decimals are nice, I'll use them. If the decimals ever end up being ugly, like reoccurring or anything like that, then stick with the fractions. Don't be putting in, don't be rounding too early in the question. 3.15 divided by 4.5. I get 0.7 plus 0.7 by t minus 44.1. So just try to be a bit logical there. Obviously, if you need more paper in the exam, utilize the back of the book, the back of the exam. Don't be trying to squish it all into one page like a sociopath. Okay, bring all your t's to the left. Minus 3.96t equals, bring all your numbers to the right. Minus 123.48. T equals 31.18 recurring newtons. Right, looking through that, the marks breaking down as follows was, if you got this equation, you got 5. If you got this equation, you got 5. Sorry, no, that's wrong. If you got that equation or one of those two equations, I'm guessing you got 5, and then you got 5 for showing it correctly here, getting to this guy, and then 5 for your final answer. Okay, so most important in the question is your setup. That's it for 2024 question 2. Hope you found that useful. If you did, then like or subscribe, or check out the other social medias where I'll be adding extra resources. If you want something particular made, then just leave me a message on one of those platforms and I'll do my best to get around to it at some point. Best of luck in all your exams.